Yesterday we learned about this performance comparison. You can see at the first time, I think this paper was in 2018, and at the time there are not so many systems to deal with this kind of encoder and decoder and also the transformer. So they just try with this system like the pre-OpenAI, which is the state of the art, and they apply with the BiLSTM, Elmo, and attention. And at the time, there's some open API or open AI, the GPT-1. So they compare between the BERT and the existing works, and they use this kind of metrics. So this metrics I mentioned to you here. So some of the metrics you can utilize it in Python. You can use the MNLI, which is the multi-genre natural language inference. You can use QQP. This is the Quora question pairs. It means they have the kind of data set, and it is to determine whether two questions are semantically equal. And then there's also another task or the matrix QNLI. So in this task, the model needs to determine whether the second sentence is the answer to the question asked in the first sentence. SST2. This is a task from Stanford. They call it the Stanford Sentiment Tree Bank. It is a binary sentence classification task. So binary, binary means there are two options consisting of sentences extracted from movie reviews with annotation. So this is the sentiment. So the sentiment, it's this good or bad. And there's also another task, we call it COLA. It is a corpus of linguistic acceptability. It is also another binary classification task. It is to predict whether an English sentence that is provided is linguistically acceptable or not. So when you read the English, whether this English is acceptable or readable or not. Another data set or another task, we call it the semantic textual similarity benchmark. So it is to determine how similar two pieces of text are. And then there's also another kind of research using the Microsoft Paraphrase corpus. It is a data set from Newswire articles. So it is from news. And every pair, they have label. So each pair is labeled if it is a paraphrase or not by human annotators. So do you know paraphrase? Paraphrase means when you have a text, you need to change so it will avoid the plagiarism. For example, I really like pizza. So this is the original sentence. And then I can do the paraphrase. Pizza is a food that I really like. So the context or the sentence have the same meaning, but the sentence have different structure. So we call this is the paraphrase. And there's also another task, they call it RTE, recognizing textual entailment. It is a directional relation between text fragments. The relation holds whenever the truth of one text fragment follows from another text. So you can see from the example, Maybe I have the word I watched the movie. And then the second sentence, maybe the penguin is cute. So sometimes we can say that this sentence is not correlated. I'm still discussing about the movie, but suddenly it is about an animal. But maybe there is a high correlation because the movie is about penguin. Anyway, this kind of tasks, they have a lot of text and they try to figure out whether the textual has an entailment or there is a connection between the sentence or not. So you can see there are many kind of tasks. Okay? If you think that this task is good for you, okay, you can also try and you can look at the data set based on this task. Some of them they provide the data set, but some of them they do not provide the data set. For example, the SST, the Stanford Sentiment Tree Bank, they have the data set. As we already learned about the bird, some application for bird, it is related to the sentiment analysis. So if you are doing project about the sentiment analysis, you can use bird. So as you can see here, the bird encoder, it is after we have the input. Let's say this is the input. The steak was good and tasty. So as I mentioned to you, CLS, it is a token. It is to indicate the starting of a sentence. So if we have this CLS, it means this is the starting of the sentence. And then we have token. We put into the bird, and bird will give an output. So the output will be a kind of factor, and it will be feed it into the feed forward neural network plus maybe the softmax. And after that, we can predict the score, whether it is positive or negative or neutral. The other kind of application, you can use BERT to check the text pair classification. We call this is text pair classification or text entailment. It means I want to know if one sentence and the other sentence, they have a connection or not. So the CLS, it is the beginning of the sentence or the starting of the sentence. And then we have SEP. SEP means separated. The separator, it can be like dot, okay, or maybe sometimes they put comma, or sometimes they put the semicolon. Okay. This is the separator. And they want to know whether the first sentence have a relationship with the second sentence or not. You can put on the bird and bird again give you a kind of factor, and this factor will go to the neural network plus the softmax, and then we can get the result. So the result is contradiction. Contradiction means this text and this text is contradict. pandai. It rains, the sun shines. Of course, this is not related. Then the result is contradiction. The other kind of application, we can use bird for annotation. Annotation means we put label. One of the labeling, you know about the name entity recognition. Every of the word, you have the structure or the in the linguistics, okay, we can say that okay, this is person Joe Biden. So this is person went to, okay, because it is not related to any kind of entity, then we can say this is just oh, and then New York. So it is indicating about location. Okay. With the bird, okay, we can put every of this token into this bird, and then when they have the matrix or the factor as the output, we can put it into the feed-forward neural network, so we can get the output such as the name entity recognition. And BERT is famous for the question and answering, or we call it, this is the span prediction. If you are creating a chatbot, so BERT is good in order to predict what will be the best answer when you have a question. This is an example. Who detected America? So this is a question. As you know, CLS is the beginning of the sentence. And then we have a separator, sep. After we have a separator, there is an answer. Okay, so this is the answer. There is Q8. For every of this sentence, yeah, we will check. So in this case, there are two kind of layer 1 and layer 2, layer 1, layer 2, layer 1 and layer 2. And we want to check what are the best possible answer for this text. And after we have a kind of patterns, then okay, this might be the starting point, because this is the ending of the question. And then we will start. After we start, we can propose what will be the best answer to start. What is the subject, and maybe what is the verb, and what is the object, and then we will end it. So this kind of span prediction or question answering, we can use BERT. So the basic of BERT, yeah, you know that we need to employ the encoders. So the transformer that consists of encoder and decoder, but for the BERT, we just use the encoders. And there are some extension of BERT. They call it Albert. Albert, it stands for a light BERT. So if you use BERT, it is big. So if your computer is good enough, then yeah, you can apply BERT. But if your computer, or maybe if you want to apply BERT in your smartphone, of course, the smartphone has smaller capacity than the computer. So you can use the light BERT. Light means gabiota. So if you have the smaller version, Yeah, you can apply in the small device, even though maybe the performance is not as good as BERT, but yeah, we can apply BERT in the small devices. And there's also another version like Roberta, robustly optimized BERT. So if you have a good server, yeah, you can put this one. Or Distilbert. This is another variant of the Albert, small BERT. And we can use the Electra. This is another kind of BERT. We call it the pre-training text encoder as discriminators, not generators. So we will see later what is the meaning by generators. And long former, yeah, this is the long document transformer. It is for the long text. BERT is good when the sentence is short, but when the document is too long, like for example, the law document, it is very long. So you need to use another kind of text. For example, yeah, long former, it can be used for the long document. So you can take a look on the Google Colab. So I'm using the library available in Hugging Face. And there is one function, they call it pipeline. In Hugging Face, they use the library transformers. And now let's deal with one function, which is pipeline, to understand how to use BERT. So from the transformer, we import the pipeline. And now let's use the pipeline. In the pipeline, you can mention what is your task. Okay, this is the task. Suppose I'm doing the text classification. So you know the text classification means whether it is a understandable sentence or acceptable sentence or not. We are using the model. This is a free model in the transformer. So you can use BERT, base, and case. So some of the model, yeah, you need to check on the Hugging Face whether they have the proper name or not. Usually you need to use like this one, BERT, base, and case. If you are just using BERT, it will not available for your task. So I'm going to do the classification with this text. BERT is a powerful language model for NLP tests. Now I'm going to check whether it is an acceptable text or not. So the text classification result, okay, you can see. Okay, once you run, there's a kind of warning in the system. To authenticate with the Hugging Face Hub, create a token in your setting tab. Okay. I think this is free, so you can just use it for free. Okay. But for some of the model, you need to access the Hugging Face. You need to log in to the Hugging Face, and you need to get the API secret. So they call it, this is, you will be able to reuse the secret in all of your notebook. I'm not sure. You can check in your Google Colab. It runs maybe because I already registered my account in the Hugging Face. So if your notebook is not registered in the Hugging Face, you may need to have the Hugging Face account, and then you need to get the API secret to run the Hugging Face in your collab. Okay. If you look at this code, okay, so you can see they will download a kind of repository, such as this one is the Shift tensors. This is the model, and the size is quite big, which is 440 million. Okay. So you need to download this one in the Colab environment. It means if your Colab environment is quite big, then you can utilize this one. So they also download another kind of statement like JSON, and then they also have another kind of data. Let's say this is the vocabulary. And when they finish the running, so you can get the score is 0.67. Okay, then this is nearby 1, so the text is quite acceptable. Device set to use CUDA is 0, okay, because now I'm running in the Google Colab. CUDA means this is for the GPU environment. If you need the GPU, yeah, we can use the GPU from the Google Colab. For example, we can just click on the runtime, and then we can change the runtime type. Oh, I already used the GPU. So you can see here, the Google Colab provides you the hardware accelerator. If you are using the CPU, maybe it will take a long time to run a big data. But if you are using the GPU, so they can try to optimize the model. You can choose this one. And if you want to do with more optimized model, you can use with the larger GPU. But for the larger GPU, you need to purchase, you need to buy. Okay. I think the basic GPU will be enough, okay, for your project. So please try to figure out about your project, and you can use just the basic GPU from Google Colab. If your computer is already good enough, of course, you can use your computer. But if your computer has no GPU, you can use the Google Colab. And in some cases, maybe you need the TPU. TPU. Have you heard about TPU? TPU is Tensor Processing Unit. So CPU means just the computer processing unit. GPU is graphical processing unit. When you use the GPU, usually you will use it for graphic. Graphic means for video, image, because they require some more computational. If you just use the CPU, yeah, your data, such as just the common data like in the Excel or the spreadsheet, you can use CPU. If you are using more complex, let's say the neural network, in the neural network, you need to apply the tensor. Then the tensor processing unit will be better. In Google Colab, they also provide this TPU for you to run the high computational neural network. Yeah, you can also run the environment not only in Python but also R and Julia. Julia is another programming language. This is also good for the machine learning, but I think Python is more popular than Julia. Now, the second thing, you can use BERT for the sentiment analysis. So let's see if I'm using the bird. This is the task. I'm going to use the sentiment analysis. And again, I'm using the model bird based on case. And I have the word. I love using Transformers library. It's amazing. So I'm going to check what is the label. So the label, yeah, it shows that the label is label 0 and the score is 0.56 something. The question and answer. So you need to specify the task, question answering. Again, we are using the BERT model, and let's make the question pipeline or the question answering pipeline. In this case, I'm having a question. What is BERT? And then I have the answer. BERT stands for bidirectional encoder representation for transformers. It is a model designed for NLP and blah, 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 blah. So I want to know whether this is a good answer or not. So the QA result will be printed, and then we want to check the result. There will be a score, and there will be a kind of possible answer. So there's a kind of warning here. Some weights for question answering were not initialized from the model checkpoint. So you should probably train this model on the downstream test to be able to use it for prediction and inference. What does it mean? So this model already a pre-trained model. So we learned about the pre-trained model. They have the encoder, and you can use this pre-trained model for your data. But in order to improve the performance, you can see this one, the result is, the score is very low. In order to improve the score, you need to train this model on a downstream test. It means when you have your data, you can combine or you can train your data into the model. But and once you have the weight, you can do the prediction. Okay. We will do this one. We will learn about this one. We call it, this is the transfer learning. The transfer learning means I'm going to transfer my own data into the model or the pre-trained model. Let's say this is BERT, and using the fine tuning, or we want to fine tune with the parameter from the pre-trained model to do another prediction. In this case, because I do not have any data, so they just use directly from BERT, the score is very low. And the answer, it's just giving the direct answer without a kind of meaningful. So we will learn more about the transfer learning or the fine tuning next week. This is another kind of task. We call it the name entity recognition. The name entity recognition. So we are again using the BERT, and there's a kind of strategy in order to do the name entity recognition. The aggregation strategy is simple. And whenever you have a sentence, you need to have this strategy because, for example, you have the word New York. New York is two sentences. But whenever you do tokenize, when you do the tokenize, what happens? New is one token, and York is another token. Okay. For this task, it is quite difficult to know that these two actually a word and these two actually is a city or a location. So there are some aggregation strategy. If there are two words and they are located in the same, or it is located at the consecutive place, York is after new, then we can check the possibility of this aggregation. So there are some strategy. Let's just use the simple strategy. So this is the pipeline that we want to fit into the model. John lives in New York and works for Google. Then the result will be 0.56 something something something. Okay. So this is a grouping. Basically, when you have this NER, you will get the yeah, like this one. The entity group, the label 0. Yeah, what is the probability if the word in New York? So what is the label? And then you have works for Google. So what is the label? And so on. So they will split the words into whether it is a location, whether it is a person, or whether it is an organization, and so on. You can use the text generation. Okay. So we are going to learn about this one. Maybe I will explain first about the GPT before doing the text generation. Okay, there are many tasks in BERT. There are many tasks in BERT. So we already looked the tasks like the classification, sentiment, name entity recognition, and also question answering. When you do your project and if you are using those tasks, you can try to apply BERT. Now let's look at the more current pre-trained model, which is GPT. What is GPT? GPT stands for Generative Pre-trained Transformer. Pre-trained. You already trained before, and it is based on the transformer. And it is for generating a new sentences. That's why they call it Generative Pre-trained Transformer. The question why people try to develop GPT is, what if we want to generate a new output sequence? That's why the ChatGPT, they come because they know that whenever you have question, yeah, it is a kind of chat. And they are using the GPT to generate what will be the new output sequence using the transformer model. The GPT-2, now I'm comparing with the GPT-2 because the GPT-2 is the free model or the advanced models that you can access for free. After GPT-2, like GPT-3, GPT-4, GPT-5, you can access it, but you need to pay some money. Okay, so just let's look at the GPT-2 at this moment. So GPT-2 use only the transformer decoders. If you know, in the transformer, we have encoder. After we do the encoder, we have decoder. When we are dealing only encoder, we use BERT. Okay, and those variants are related with the encoder. When we use the GPT, actually we are using only decoder. So the transformer decoders are no encoders. So it means we already pre-trained this one. And we just use the decoder to generate the new sequences from scratch or from a starting sequence. So the GPT-2, they are just utilizing the decoder. So they try to generate a new decoder. In the BERT, they try to generate a new encoder in order to do some tests. In the GPT-2, the basic GPT-2, there is no attention. But now the new GPT, they have the attention. And yeah, they develop the self-attention. So there is no attention since there is no transformer encoder. Because there is no transformer encoder, so they have the pre-trained model and then they use the decoder only. So there is no attention and they apply the self-attention. As it processes its word or token, it masks the future words. So the word masking. The word masking or mask, it means I am hiding the future words and conditions on and attends to the previous words. So here I have the sentences. Okay. After I have the sentences, we can put this into the self-attention. If we want to do a kind of prediction, so we can mask the self-attention. The mask self-attention means I'm hiding this one. So I will hide this one. And then I'm just utilizing the previous words in order to predict what will be the next sequence. So technically, it does not use words as input. So the input is not word, but it is byte pair encoding. Okay, so this is the most important thing in the GPT, or sometimes they call it the subwords. It includes positional embedding as a part of the input too. So you already learned the positional embedding. We use the sinus and cosinus. That's the basic positional encoding. Sorry, positional embedding. So using this kind of byte pair encoding, yeah, people say that it is easy to fine tune on your own data set. So if you have your data set, yeah, you want to generate a new text, yeah, that will be easier. So I'm not teaching the detail about the byte pair encoding, but you need at least to know this one, the byte pair encoding. It is the basic of the GPT. It was invented in 1994 and it was updated in 2015. It looks at the individual symbols. Individual symbols means individual characters. And repeat merge the most frequent pairs. If you learn in the data mining, data science, there is the method agglomerative clustering. So they try to do the clustering. For example, if I have the word the character L. Okay. After I start with I, and then I have the letter L. What is the most probable next word? Or what is the most probable next character? So I can do with O, I can do with I, or maybe I can do with A. So it depends on the clustering result. What will be the context from the previous history? If the previous history is mostly about something he likes or she likes, then maybe the word may be like. So it will make a kind of prediction based on the character. It will stop after n merge. So you can specify the n. So the GPT use n equals to 40K. So it means 40,000. So once you generate a kind of sentences, it is a kind of sequences for 40,000 characters. So that's the basic of the BPE or the byte pair encoding. Okay, let me stop here. Let's have a break. Okay, I will continue for the bit.